Okay, so we're going to look at this problem 5.2.5, or section 2 of chapter 5, problem number 5. And we're looking at probability distributions drawn from a normal population. And in this case, we have a variable x that's being drawn from a normally distributed distribution with a mean of 84 and a standard deviation of 4. And so we want to find the probability that if we pick an x value, that x value is going to be between 74 and 77. So what we want to do here with any of these probability problems is kind of sketch our normal curve. So let's sketch our normal curve out here and mark some areas of interest on it. So the first thing we want to mark is, well, our mean is going to be 84. And then the values we're looking for, I'll accent them a little bit heavily, are both below the mean. And so we're looking for between the values of 74 and 77. So they're less than the mean. Now the probability is the area in the normal curve in between these two values. So our key tool in finding probability areas are going to be z-scores. And so we're going to need to find the z-scores for these two values. And then we need to find how to get the area between those two values. And our technique for that, if we remember back from our probability, is we subtract the probability of the largest score. We subtract from that the probability of the lowest score, right? Because it tells area from the left to the right. And so we're going to use the left to the right probability to get it. So right, we want to get the area up to 77 minus the area up to 74. And that'll leave behind the sliver that we're looking for. And so our Z tables become our friends in all of this. You're going to find that we use the Z tables a lot. Now, one of the things that's nice about this particular set, and we can get from if we look at our data, is we are all to the left of our mean. So these are going to be negative Z's. And so our Z calculation is going to be our X value minus the mean divided by the standard deviation. So the Z for the highest score is going to be 77 minus 84 over 4, because our standard deviation was 4. And so 77 minus 84 is negative 7/4. Or as our calculator would put it, negative 1.75. And our lowest Z value is 74 minus 84 over 4, or negative 10/4, which is negative 2.5, I believe. So what we want to do is we want to turn these into probabilities. And so we have to come to our Z table and look up our Z scores. So let's get the area for the probability of Z of H. Looking at our table, and the probability of Z of L, looking at our table. So Z of H will come over here to our table. Let's see if I still have my table sitting up here. Yep. And we had negative 1.75. So let me come to 1.7. Negative 1.7 is here over to 5. And that gives me a 0.0401. 0.0401. So 0.0401. And then I come from my low, which is negative 2.5, so negative 2.5 with a 0, and that's 0.0062. Wait, sure I'm on the 0.5 in gray. Yeah, 0.0062, right? Negative 2.5 with a 0 in the thousandths place. So I follow that over to 0.0062. So I'll put both of these now in here. We've got 0.0401 and 0.0062. Well, the probability of x being between 74 and 77 is the difference of these two probabilities. And now I'll grab my calculator over here. 0.0401 minus 0.0062 is 0.0339. 0.0339. And I'll double check what we wanted with the problem. And it said to 4 decimal places. So we have our 4 decimal places. And so this is a good example of using our tables to generate our probabilities. The key with these standard normal, draw the regions you're looking for. Identify your mean and identify the values, your boundary values. That'll help you figure out which Z tables to look at and what you're subtracting from the other values. And we want the area in between the in between the boundaries. So when you have a double boundary like this, you want the highest one minus the lower one on your probabilities. And lucky for us, our Z tables will pull all those values out for us. And so it's a question of flipping to the back of the book or pulling out that table and looking up the relative numbers.